on the previous modules, event sourcing should sound quite appealing. You get an evidentiary log. You get fast reads and fast writes. You get a behavioral view that can be used for analytics. So what's the catch? Event sourcing is harder to implement than traditional state-based methods for a number of reasons. In a traditional system, there is often just an application in a database. In a CQRS system, there is at least one more moving part: the Kafka topic that separates the write side of the application from the read side. A second complexity is that as applications evolve over time, the data model changes also. This leads to events with many different versions of the same schema being stored inside a single topic. Some schemas old, some more recent. This is similar to what happens in schemaless databases like Cassandra or MongoDB. As the number of schemas increases, different parsing code must be added to understand each one. This is a perfectly valid strategy for building software, but it adds complexity to the system nonetheless. Finally, any CQRS-based system is eventually consistent, meaning you can't necessarily read your own writes. So there's a little bit of extra complexity with CQRS, but the model works well for many different kinds of use cases. A good example of this working well is the New York Times website. This application stores every single edit, image, article, and byline from the newspaper right back to 1851. All this data is stored in a single Kafka topic. The raw data is stored as events, which are summarized into tables to be delivered on the website. This use case works well because the CMS, where the content originates, doesn't need to be immediately consistent with the serving layer. So being eventually consistent works well. But event sourcing isn't the only approach we can take to provide event-level storage as our system of record. Change data capture provides most of the same benefits without changing the underlying data model. In this figure, we have a mutable table in the database representing the shopping cart. A CDC connector pulls events from this table as rows are added or changed. These are pushed into a Kafka topic where they can be consumed by other systems. Because CDC records changes at an event level, we get all the evidentiary benefits of event sourcing. Sadly, unlike event sourcing, the mechanism is not replayable. However, the outbox pattern can be used as a means to rectify this. In the outbox pattern, there are two tables: a regular table that we mutate and an events table that is append only. A trigger is used to append entries to the event table as writes and updates are made to the original table. If the database doesn't support triggers, then the updating application needs to write to both tables in the same transaction. The events table is then CDC'd into Kafka. The advantage of this approach over the regular CDC approach is that you can easily replay events directly from the database as they are stored there in full.